simplifying radicals, which is basically figuring out an easier or simpler way to express a square root. Now, the square root of 24, if you were to put that in your calculator, you would find out it equals about 4.899. The problem with just putting something in your calculator is twofold. First of all, what if you don't have your calculator with you? Then that would be pretty tough. And second of all, this had to be rounded. It wasn't 4.899 in the calculator, it was 4.8 blah, 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 blah. And I don't even know, the calculator might have even rounded it off. So this is not an exact answer. Simplifying a radical gets you an exact answer that doesn't require anything to be rounded. And there's many ways that your teachers might teach you to simplify a radical. They might teach you the perfect square method, where you divide out perfect squares from what you're trying to simplify, and then take the square root of that perfect square and leave the rest inside the radical. They might teach you the tree method, where you just think of two numbers that multiply to what you're trying to simplify, and then keep breaking it down until you end up with primes, and then circle any pairs you get, and they come outside and the rest stay on the inside and get multiplied back together. Or you could do the way that I found is the easiest way to simplify a radical, and that's by dividing out primes, but not with a tree method. It's more of a straightforward fashion. So let's divide 24 by primes, and you might hopefully remember that primes are things like 2, 3, 5, 7, 11, 13, and it really goes on forever, but those are the first primes. Now remember, a prime is a number that can only be divided by itself, or 1. And so what we're going to do is we're going to divide 24 by primes. So for example, 24, we could divide that by 2. That would get us 12. Now we'll divide 12 by a prime. That gets us 6. Now we'll divide 6 by a prime. That gives us 3. Now we can't divide 3 by 2, but 3 is a prime, so we'll divide 3 by 3. That gets us 1, and basically 1 and you're done. Once you get, and you've divided all the way to 1, you're done. So what we've done is we have divided 24 by 2, 2, 2, and 3. And so now, since we're finding a square root, we circle a pair of primes. Now that pair you can write on the outside of your radical, and guys who are left inside, 2 and 3, multiply them back together, that gives you 6. And that is the basic method. So in 1 second I'll come back and I'll show you some more examples. Okay, so now I came back with 3 more examples for us to simplify radicals. I have 2 where we're going to simplify square roots, and I've got 1 where we're going to simplify a cubed root. Okay, so let's start with the square root of 50. So we're going to divide out primes, and then we're going to look for pairs, because a square root is what number times itself makes the number inside the root. So that's how come you want to look for pairs. Something times itself is the square root. Okay, so the square root of 50. Simplify that out. So let's go ahead and divide 50 by our first prime. How about a 2? That gives me 25. So I'm going to write a 2 to show that I divided that out. 25, can't divide that by 2, but I could divide it by the prime 5. So 25 divided by 5 gives me 5. So I'm going to show that I divided out a 5. Still got to keep dividing all the way until 1. So let me divide a 5. And the only thing you can divide that by is itself. So that gets me 1. And I'm going to write down that I divided out a 5. Now, like I said, square roots are pairs of numbers, something times itself. So here's my pair. So that can come to the outside. The 2, we never found his pair, so he's going to stay inside the radical. So the square root of 50 is the same as 5 square root 2. Let's try the square root of 300. All right, maybe a different color. Blue. Okay. So 300. Let's start dividing by prime. So how about a 2? That gives me 150. Write it down to show that I divided out that 2. 150. Let's divide that by another 2 since we can. That's going to give me 75. So let me write down that I divided out that 2. 75. Let's divide that by a prime. Now you can't divide it by 2. You could divide it by 5 though. So how about divide it by 5? That's going to give me 15. So let me show that I divided out a 5. Okay, 15, I could divide that by another 5. That would give me 3. So let me show that I divided out another 5. 3, got to divide it one more time. 3 is a prime. And it's going to give you 1, and I'm done. So let me show that I divided out a 3. Square roots are pairs, something times itself. So the pairs I have are 2 and 5. So they both get to come to the outside of the radical. You'll notice I only write it once. And then the 3 is left over, so he stays inside because he never got his pair. The 2 and the 5, just multiply them back together, so I give you 10 root 3. Is the simplified version of the square root of 300. Okay, now let's talk about when we have to do a cube root. Well, you know, a square root is something times itself. It's a pair of primes. A cube root is something times itself times itself. It's going to be a set of triplets. So now let's try to do the cube root of 189. So we're going to be looking for triplets of primes. So 189, what could I divide that by? Let's maybe divide it by 3. That would give me 63. So let's divide it by 3 to get 63. Let's write down that I divided out a 3. All right. Now let's divide 63 by a prime. Just taking a guess, probably another 3. So if I divide 63 by 3, I get 21. So let me show that I divided out another 3. Okay, now let's divide 21 by a prime. Now 21, I can divide that by 3 or 7. Let's just keep up our streak of 3s. Divide it by 3, that's going to give me 7. Show that I divided out another 3. And then 7 itself is a prime, so it can only be divided by 7. That gets me 1. 1 and I'm done. So let me show that I divided out that 7. Now this time I'm looking for a cube root. So now I'm going to circle a set of triplets. And then that can come to the outside. The 7 can stay left over on the inside. The cube root of 189 is 3 times the cube root of 7. And it's just as easy as that.